Lecture 85. Famous scientific bets and challenges title screen with cosmic background and shadowy handshake silhouettes. Welcome to the enigmatic world of scientific wagers, where brilliant minds don't just debate theories, they bet on them. I'm your host, and today we're venturing into the mysterious realm where scientific conviction meets personal pride, where theories aren't just published, but wagered upon with brazen confidence. What compels the greatest scientific minds of our time to place bets on the fundamental nature of reality? Perhaps it's the same hunger for truth that drives all discovery, distilled into its most primal form, the willingness to stake one's reputation on the unknown. Split image showing Stephen Hawking and Kip Thorne with a black hole visualization between them in the shadowy boundary, where theoretical physics meets cosmic mystery. One wager stands above all others. The year was 1997, and three titans of physics, Stephen Hawking, Kip Thorne, and John Preskill, found themselves entangled in a paradox of cosmic proportions. The question that haunted them was deceptively simple, yet profoundly perplexing. When information falls into a black hole, is it lost forever? Stephen Hawking believed yes, that the information was irretrievably destroyed. Kip Thorne and John Preskill insisted no, that somehow the information must be preserved. The stakes? Not money, but something far more valuable in scientific circles, a definitive encyclopedia. If Hawking lost, he would provide his opponents with an encyclopedia of their choice. If they lost, they would each offer the same to him: visualization of Hawking radiation and information escaping a black hole for 7 enigmatic years. This cosmic gamble remained unresolved until 2004. When Hawking made a stunning announcement at the 17th International Conference on General Relativity and Gravitation in Dublin. In a breathtaking reversal that sent shockwaves through the scientific community, Hawking conceded the bet. "I'm sorry to tell you that you have lost your bet," Hawking told Preskill as he presented him with a baseball encyclopedia. "Information is not lost in black holes." Thorne, however, refused to concede, maintaining that the paradox remained unsolved. This wasn't merely a scientific disagreement. It was a fundamental clash over the nature of reality itself. Whether the universe preserves information as a cosmic principle, or whether black holes represent singular cosmic exceptions where information vanishes from existence. Image of the Longbets Foundation website with highlighted scientific bets. While the Hawking-Thorne-Preskill wager might be the most famous, it's far from alone. In the early 2000s, an intriguing institution emerged: the Longbets Foundation. Created by Stuart Brand and Kevin Kelly, this foundation serves as a sanctified ground for long-term scientific wagers, where predictions must extend at least 2 years into the future. The stakes aren't trivial. Minimum bets start at $1,000, with proceeds going to charities of the winner's choice. But the true currency is intellectual credibility. When scientists publicly stake their reputations on predictions, they're forced to articulate their reasoning with crystal clarity, knowing their words will be preserved for posterity. Among these bets, will the Large Hadron Collider discover supersymmetric particles? Will commercial quantum computing become viable before 2030? Will we make contact with extraterrestrial intelligence by 2050? The bets themselves become mirrors reflecting our deepest scientific uncertainties. Historical illustrations of Darwin and Wallace, with timeline of their relationship, let us travel back to the misty corridors of scientific history, where perhaps the most consequential scientific wager unfolded without formal documentation. Charles Darwin and Alfred Russel Wallace, co-discoverers of natural selection, engaged in a most peculiar intellectual duel. Though not a monetary bet in the traditional sense, their parallel development of evolution through natural selection created a race to publication that would forever alter our understanding of life itself. Darwin, having developed his theory over decades, was spurred to finally publish when Wallace sent him a manuscript outlining strikingly similar ideas. The Resolution, a joint presentation to the Linnean Society in 1858, followed by Darwin's publication of On the Origin of Species the following year. This silent wager, this race to priority, transformed biology forever, showing how scientific competition can catalyze revolutionary ideas. Dramatic visualization of meteor impact and dinosaur extinction in the late 1970s, Physicist Luis Alvarez and his geologist son Walter proposed a theory so outlandish it was met with overwhelming skepticism: that the dinosaurs were wiped out by an asteroid impact. The scientific community scoffed. Where was the crater? Where was the evidence? This wasn't a formal bet with signed documents, but rather a profound challenge thrown down before the entire paleontological community. The Alvarez team essentially wagered their scientific credibility against the established wisdom of an entire field. Find the crater was the implicit challenge. Prove us wrong. For years, the search continued until the discovery of the massive Chicxulub crater in Mexico's Yucatan Peninsula. The evidence was undeniable: a 110-mile-wide scar from a cosmic bullet that changed Earth's history. The Alvarez hypothesis had won its unspoken bet against conventional wisdom. Time series showing the intensity of the scientific debate, with quotes from both sides. What makes this scientific wager particularly captivating is how it transformed from fringe hypothesis to scientific orthodoxy. The resistance was fierce. Paleontologists had their own gradualist explanations for dinosaur extinction. But the Alvarez team had staked their reputations on a single dramatic event. The evidence accumulated like a slow-building wave: the iridium layer at the KT boundary, found worldwide, the shocked quartz, the microtectites, the pattern of extinction itself, each discovery tipping the scales further in favor of the impact hypothesis. By the early 1990s, the silent wager had been resolved. The asteroid impact theory had prevailed, not through rhetoric or authority, but through the relentless accumulation of evidence, the only true currency in scientific betting. Images of DARPA Grand Challenge vehicles and X-Prize spacecraft in our modern era. Scientific wagers have evolved into formalized competitions with substantial prizes. The DARPA Grand Challenge offered millions to teams that could create autonomous vehicles capable of navigating difficult terrain without human intervention. The first challenge in 2004 saw all vehicles fail, with none completing even 10% of the course. Yet by 2005, 5 vehicles completed the entire 132-mile course. The X-Prize Foundation has established numerous challenges, from private spaceflight to medical diagnostics, with prizes often exceeding $10. These aren't mere competitions, they're structured scientific wagers, betting that innovation can be accelerated through competition and reward. What separates these modern challenges from traditional scientific bets is their focus on technological application rather than theoretical correctness. They ask not what is true, but rather what can be accomplished. Visualization of competing theories with scientists' faces and connecting lines showing relationships, while formal scientific wagers capture our imagination. Countless informal bets permeate the scientific community. From friendly departmental wagers on experimental outcomes to heated conference disagreements settled years later, these bets form an invisible network of accountability. Consider the ongoing wagers surrounding quantum computing. Will quantum supremacy be maintained? Will practical quantum computers arrive before 2030? Billions in research funding hang in the balance of these implicit bets. Or the field of artificial intelligence, where competing camps have placed implicit wagers on whether deep learning alone can achieve artificial general intelligence. The resolution of these unspoken bets will shape our technological future in profound ways. Philosophical image showing scales balancing evidence and belief. Why do scientists bet? The answer unveils something profound about the scientific enterprise itself. In a realm where certainty is elusive and proof often decades away, bets serve as commitment devices, forcing clarity of thought, precision of prediction, and accountability for one's theories. When Stephen Hawking conceded his black hole bet, he demonstrated perhaps the most essential quality in science: the willingness to change one's mind when confronted with new evidence. Far from admitting defeat, his concession represented the pinnacle of scientific integrity. Scientific betting embodies the tension between conviction and doubt that drives discovery forward. Strong enough conviction to stake one's reputation on an outcome, coupled with enough doubt to accept being wrong, this paradoxical mindset is the beating heart of scientific progress. Forward-looking image with question marks and future scientific challenges. As we gaze into the scientific horizon, What new wagers await resolution? Will we detect dark matter directly? Will fusion energy become commercially viable? Will we find evidence of life beyond Earth? The most profound questions in science remain open, awaiting not just answers, but brave souls willing to stake their reputations on those answers. Perhaps you, watching this now, will someday place your own scientific bet, adding your voice to this ancient tradition of intellectual courage. For in the end, every hypothesis is a wager against uncertainty, every experiment a bet placed on reality's hidden nature. Thank you for journeying with me through this enigmatic landscape of scientific gambling, where the highest stakes aren't measured in money, but in our collective understanding of the universe itself. Until next time, keep questioning, keep wondering, and perhaps, keep betting.